hypothesis.
Okay.
We should accept the null hypothesis, right? If it is more than 1.96, we should reject the null
hypothesis.
Are you written? Have you written, madam, or not, madam?
Sir, I written, sir. I written. Actually,
Yeah.
I was searching that book.
Okay, okay. So this is very, very important, right? So now here, right, if it is less than 1.96, so we are going to accept the null hypothesis, which means there is no skewness, which means the data is normal. So to have data normal, our Z value should be less than 1.96. Is it okay, madam?
Yes, sir.
Tell again, madam. Tell again what I have discussed. Tell. Be normal. Tell, madam. To be normal.
To be normal.
Value should be.
Value should be less than 1.96.
Yes. Z value should be less than 1.96, which means there is no skewness. Right? Okay. So now what is Z value? Z value is skewness divided by standard error. Right? T value, Z value is skewness, whatever it is, that gets estimate divided by standard error. The estimate may vary according to the what analysis we are using. But estimate divided by standard error, it is common to entire statistics. Only one. Estimate divided by standard error, that is applicable to all. All right. So this concept, the T value concept also applicable to all. Right. So only few terms are there. Only few terms. Okay. How to frame null hypothesis? We are trying to find out whether there is skewness. So null hypothesis, there is no skewness. That's all. Matter over. What we want to find out? Null hypothesis, there is no. Hello?
Yes, sir.
Okay. So now we are going to continue. Okay. I will not leave you, madam. So we are going to continue. Okay. So with that, okay, because we will take up some data. So yesterday we have done with see, I have sent one Word file how to write interpretation for standard deviation, right? Because many people, they are using standard deviation, but they are not writing anything. So I have given one Word document how to write up standard frequency, how to write for frequency, all these things I sent it to you. So now, okay, so let me rerun. Okay, so now I'm going to run all right. Where I have to go, madam? Yeah.
It's not visible, sir.
For analysis.
Not visible. Okay, I will make it visible. I will.
Please share your screen.
Now is it okay, madam?
Yes, sir. Yes, sir.
Yeah. Now you have to tell me what I have to do. All right.
Okay.
How to find out the distribution and other things. Where I have to go.
Analysis.
Analyze, not
Analyze.
read, madam.
Analyze. Okay, sir.
Analyze.
Descriptive statistics.
Descriptive statistics. Yes.
Okay. Next to frequency.
Frequency also I can go. Yesterday we went for something else.
Explore.
Explore. Right. In the if it is frequency, you have to click.
Okay.
Okay. If it is explore, you need not click. It will come automatically. Explore. Right. Next. What I have to do, madam?
Select it.
Let me take that variable and put it here. Next. Okay, the plots, normality with this.
Normality, plots with
Okay,
test.
this histogram also. Stem and leaf automatically clicked.
Stem and leaf, okay.
Okay, So now we have, okay, so I can give meaning for all, but okay, so what is this confidence interval? What is this one? It is there in the PPT. It is there in the PPT for the same value calculated. It is there. Same example, it is calculated. It is there. Okay. So now the median is 31. What is the meaning? Median is 31.
Median middle value, that is
Yes, madam.
middle value, sir. Median means
No, median 31 means what?
it is second quartile.
No,
Sorry.
median 31 means what, madam? Median 31, what is the meaning? Madam, are you written?
Yes, sir.
Please read, madam, what you have written.
I written for it is one of the exactly 50% middle value.
Not exactly. 50% of the people
50%.
are less than that.
Okay.
Okay, so 31, if you take 31 age, so
Hmm.
50% of the people are having age less than 31, 31 and less. That is the meaning. Hello?
Yes, sir.
That you have to tell, madam, 50% middle. I've told you no middle. Right. Okay, so what is okay? So median is there, right? The standard deviation is 7. So what is variance? Variance is standard deviation square. Minimum we know, maximum we know. Range. What is the range, madam?
Measure of dispersion.
The difference between
46.
minimum and maximum range.
46.
Right? The difference between
Minimum and maximum.
that is the range, madam. Range.
Oh,
Simple.
yes, sir, yes,
Range
sir.
from this one to this one. Okay, very good. Now, what is interquartile range? Interquartile range. It is the difference between
Searching for it, where it is.
range, interquartile, two quartile, Q1 and Q3.
Yes, sir. Yes, sir.
You have not written, madam?
Yes, sir. I written, sir. I'm searching here. Yes, sir.
There you
Q1,
have written.
Q1 minus Q3, right?
The difference between
Yes, sir,
Q3,
yes, sir.
Q3 minus Q1.
Okay, okay, sir.
Q3 minus Q1. Okay, very good. So what is Q1? 25% of the people less than that. What is Q3? 75% of the people less than that.
Yes.
Right, very good. So now here, okay, please, now we are going for our method. Now we are going to check whether our data is normal or not, right? So now how to verify? Skewness divided by standard error. What is the skewness value?
0.082.
No,
Sorry,
what
sir,
is
sir, sir.
skewness
That
value,
is
madam?
statistic. That is 0.394, no, sir.
What is the skewness value, madam?
0.394, sir.
0.394, right?
Yes,
Right.
sir.
What is the standard error value? 0.082,
0.082,
right? Now
Yes,
we
sir.
have to find out Z value. Z value equal to 0.394 divided by
0.082.
0.082, right? Okay. So now the calculated values are my PPT is visible, madam.
Yes, sir. Descriptive statistic.
Good, madam. Good, madam. Good, madam. Yeah, yes, sir. Go, sir. Okay. So now, okay. So the range is minimum and maximum. Okay. So median, all these things written. The Z value is equal to 0.394 divided by 0.082, which is equal to 4.80. 4.80.
It is more than 1.96.
It is more than 1.96.
We should reject the null hypothesis.
We should reject the null hypothesis.
Yes, sir.
Which means
It is.
no skewness
There
is
is no
detected.
skewness.
No skewness is rejected. What does it mean?
Null hypothesis. There is no skewness.
No, madam. The
Sir, it is more than
null
1.9.
hypothesis is there is no skewness, which is rejected. When null hypothesis is rejected, what we have to do? We should accept the alternate hypothesis, which means
No skewness.
madam, null is there is no. What is alternate?
Alternate. With alternate is selected, sir.
Madam, null hypothesis is when there is no skewness. Alternate is there is a skewness.
Yes, sir. Yes, sir.
Right? When there is no association, alternate is there is an association. Right? So now here, since the t value is or z value is more than 1.96, null hypothesis rejected, which means no skewness is rejected, which means there is a skewness. Is it okay?
Oh, okay, sir.
Is it okay?
Okay, sir.
There is a skewness, right? Now, there are two kinds of skewness. One is positive skewness, another is negative skewness.
Okay.
Right. So now how to find out? Now we have to look at, now there is a skewness, right? What is the skewness value? 0.394. 0.394. That is the skewness value, not Z value. We have to look at the skewness value. Okay, it is 0.394. Is it positive or negative? 0.394.
Positive. Positive.
How do you say positive, madam?
There is no that is.
There is no minus.
Yes.
See, if it is minus, there will be a minus sign. When there is no sign, which means positive, which means there is a positive skewness. There is a positive skewness. Okay.
Okay.
Okay, very good. So next, okay, so there is a positive skewness, right? Very good. Next, okay. Now let us go to, okay, let us go to kurtosis, right? Now what is the, now let us go to the kurtosis. Now here kurtosis value is, okay, what is the kurtosis value, madam? Minus 0.248.
0.248.
Okay, what is the standard error value? 0.163. Okay, so minus, leave alone the minus. Okay, so 0.248 divided by, okay, same thing everywhere, world concept. That estimate divided by standard error is the world concept, right? Everywhere. So 0.248 divided by 0.163, which is equal to 1.5952, which is less than 1.96. So we should accept the null hypothesis. Less than 1.96.
Less than 1.96.
We should accept.
Yes, sir.
Okay. Less than. See, we are telling based on Z value, not on significant value. That you have to remember. So significant value means we will look at the opposite, because when the t increases, significant value will come down. So entirely opposite. So now since it is less than, okay, 1.96, right? We should accept the null hypothesis. What is the null hypothesis? There is no kurtosis. That is the null hypothesis. There is no kurtosis. We are accepting the null hypothesis, which means there is no kurtosis. Hello?
Yes, sir.
Very good. Very good, right? So now here I've explained how, okay, so the confidence lower bound, upper bound, how it is calculated. I explained, right? Okay, so you know IQR is interquartile range, right? Interquartile range. Okay, now Okay, now I'm going to tell, okay, so this not at over, madam, what is positive skewness, what is negative skewness, how to write interpretation for positive skewness, how to write interpretation for negative skewness, everything is interesting, okay, but you people won't use much, so that is why only to check normality I have described. When there is skewness, which means not normal. When there is kurtosis, which means there is not normal. That you need to know. Right? Very good. So now I'm going to tell one another thing. One another thing. Right. Now, see this. We will look at this box plot.
Box
Right?
plot. Yes.
Box plot. Right. So now we will see. We might be having a box plot. Now let us see the box plot, and we will come back.
Yes, sir.
இப்ப நீங்க தான் சொல்ல போறீங்க பாக்ஸ் பிளாட். சரி, பாக்ஸ் பிளாட் தெரியுதா மேடம்? கேன் யூ see பாக்ஸ் பிளாட்?
Yes, sir. Yes, sir.
ஒன்னொன்னு you have to tell what is this line?
That is middle line. That
What
is
what
the
is-
second one is that is median.
Very good, மேடத்தை கை தட்டுங்க. Median, very good. Very good, right. This line?
That is first quarter. That is
Very good. Q1. That is
Q1.
the Q1, right. 25%, right.
Yes,
What
sir.
is this one?
That is Q3, sir.
Q3. What is this one?
That is minimum.
Minimum. Here?
Maximum.
Very good. Very good. So now,
Yes, sir.
here, these two values are outliers. Okay. So you please note down, okay, the case number, case means respondent, right? 389 and 329 are the 389, 329 are the outliers value, right? Right. So now here you please see the maximum here. Maximum is approximately something around 54 something. Yes or no, madam?
Yes, sir. Yes.
Right. But if you look at the data, here it is taking maximum 54. But if you look at the data, now you can see maximum, which is maximum is 64.
54.
But it is taking 54. What happened to 64? 64 is outlier. It tells 64 is outlier.
Okay.
Sir, how it has
How it is
identified, sir? How it has identified? Why it has taken 50? See, it should have taken maximum 64, no, sir. Then why it has stopped with the 54, sir? How it is calculating, sir? Right? How it is calculating, sir? That you need to know. How it is calculating. Okay. Now for which, okay. So now, right. So now we know IQR. What is IQR? Interquartile
That is
range.
interquartile.
Right? What is the Q3 minus Q1? What is Q3? 37. Right? Shall I say Q3? Shall I show Q3?
Yes, sir.
I will show Q3. Right. Then we will see. Yeah. Right. Okay. So. Okay. Based on frequency, you can see, but. Let me put the frequency analysis right here. So statistics, right? Let us put a percentile, right? Okay. So the skewness value, all you'll get all. Okay. So, oh sorry, percentile. What else? Minimum and maximum that you have seen, that is not required, right? Okay. So now what I want to show. Okay. So now you can see what is Q1 25. Yes or no, madam?
Yes,
Q1
sir.
is 25.
Mm.
Q3 is 37.
37.
Now IQR is 12. Yes or no?
Yes, sir.
Okay, 37 minus 25 is 12. So that is what it has shown here. IQR is 12. IQR is
Okay. 12.
IQR is 12, right? So now I'm going to use the IQR, right? That is why it is showing IQR. Now, how to identify the minimum or maximum, right? So now we know our minimum is
25. 25.
What is the minimum age? 18, right? Here minimum age is 18.
Yes, sir.
Minimum age is 18, maximum age is 64. Q1 is 25, Q3 is 37, right? So now we need to find out minimum, right? How to find out minimum? So now, sir, சொல்லுங்க. Yes. Okay, sir. Thank you. Okay, thank you, sir. Sir, is it okay, sir?
Sir.
No, Sivakumar sir has asked. Very good. Okay, very good. Very good, sir. Thank you, sir. Okay, so now
Continue, sir.
so many people they have raised their hand. Very good. So now, madam, I am going to find out minimum. How to find out minimum? Minimum is that
Okay.
is see Q1, right? Q1. See, minimum is less than Q1, right, madam? Maximum is above Q3. Am I right?
Yes, sir.
Yeah. Now my Q1 is 25.
Okay.
25. It should be less than, right? 25. 25 minus 1.5 into IQR, interquartile range. That is the formula. Q1 minus 1.5 into IQR. That is the minimum. Now here 1.5 into 12, which is equal to 18. So 25 minus 18, 7, right? So up to 7 it can go, but our minimum is 18. That is why no outlier in the bottom. Right. So now let me go to the upper side. Upper side is Q3 above, right? Q3 plus 1.5 into IQR.
Sir, what is that 1.5?
No, that is the formula, madam. 1.5
Okay.
times.
Okay, sir. Okay, sir.
1.5 times of IQR.
Okay, sir.
1.5 times, 1.5 times, 1.5 times of IQR. That is the meaning, right?
Okay.
So now 1.5 into 12 is 18. So 37 is the Q3. Q3 plus 18, 55. If any value more than 55 is outlier.
Okay.
Now here, that is why in the box plot, right, in the box, let me go to the box plot now. So here in the box plot, it is, okay, so it is showing maximum is 55. Okay, so which means there are two cases, 329 and 389. Those two are outliers. Is it okay?
Yes, sir.
Okay, now let me go and see. Let me go and see whether they are okay. So now this is my data. Can you see the data set, madam?
Yes, sir. Yes, sir. Yes,
Yeah.
yes,
Now
sir.
let me go to 329. Right. If it is 50 more than 55, it is outlier 3. 329. What is 329? What is the value, madam? Frequency 329. It is not visible.
329.
What is the value? 60. Can you see 60, madam? 329. Hello?
Yes, sir. Yes, sir. Yes, sir.
3. That is why 329 is outlier. Now let me go to 389.
Okay.
389 is 64. That is why it is outlier. Is it okay?
Yes, sir.
Okay. So by using box plot, we can identify the outliers. See any value, right? Maximum is Q3 plus
Plus 1.5
1.5 into IQR. Okay, minimum is
Q1 minus
Q1,
1.5 into IQR.
Very good, madam. If it is less than that value, that is outlier, or above that value, that is the outlier. Is it okay?
Yes, sir.
Very good, madam. Right. So that is the way box plot is used, IQR is used, right? Okay. So now I'm going to tell there is another way of, okay, there is another way of, all right, another way of finding out outlier. There is another way of finding out outlier. Now we know that 329 is 60, 389 is 64. Yeah, very good, madam. Very good. I think you have noted down. Good, madam.
Yes, sir.
You have to note it down. Very good. Now what I am going to do is, right, I am going to do another method.
Oh, sir. Okay, sir.
Analyze
Okay.
descriptive statistics,
Okay.
descriptives. Then I'm going to put that value here. Now I'm going to save standardized value as variable. Save standardized value as variable. What I'm doing is I'm going to save the standardized value as a one variable.
Okay.
Right. I'm going to save the standardized score, or otherwise it is a Z score, not Z value, Z score. So now let me go and see the Z score. Now I have this value. Okay, I have this value. Now any value greater than 3, right, whether it is -3 or +3, right? If it is more than means look at the absolute value, not this, right? More than 3, then it is called the outlier. Now let me go and see 329, right, madam? 329. 329.
60.
Okay, 329. What is the value, madam? Is that value?
3.
Is it more than 3 or less than 3, madam?
Yes, sir. More than 3, sir.
That is why I applied. Look at the all other values. Look at the all other values.
It
All
is
other
1.
values. Less than. Okay, it should be less than. Now let us go to another one, 389.
Sir. 364.
389. Okay, so 64. Look at the 4.
It's more than 3. Sir, it is always more than 3, no, sir? Not less
Yes,
than
ma'am.
3.
Okay, no, but everything should be more than 3. More than 3 means outlier, right? So let us, some people don't fight with me. If it is minus, okay, don't look at the minus value or plus value. If it is minus 3.2, then it is more, we call it as more than 3. Okay, actually in a minus it is less, we have to tell. That is why I'm telling, look at the absolute value. Absolute means ignoring minus. Okay, ignoring minus or plus, right? Okay. So if it is any value, right? Why it is positive? Because in the upper side, okay, so there is a outlier. If it is a downward side, it will be minus. It will be minus, right? So this is the way you have to identify the outlier.
So we should consider minus and plus, whether minus or plus 3 or only positive 3.
No, no.
Anything, madam, whether it is,
Okay.
see, madam, outlier can appear above side or bottom side, madam.
Okay, sir. Okay.
If it is out upper side, it will be plus more than 3.
Plus 3.
If it is bottom side, it will be
Minus.
minus more than 3.
Okay, sir. Okay, sir.
Clear?
Yes, sir.
Very good, madam. No, you ask, madam, because like you, many people will be there, no, madam. So that is why I'm asking you, right? See, whatever doubt you have, other people also they might be having, but we are not allowing them to ask questions. Otherwise, they might have asked. They will be asking. So some people they are going on raising the hands. Okay.
Okay, sir. Okay.
So the many people are putting the chart also. They are putting. Okay, many things. I'm not looking at the chart and other things. Okay, so now this is what how to identify. Very good, madam. But with this, I can stop. But there are many interesting things are there. I'm not telling. Okay, now let us look at the graphs. Let us look at the graphs. Right here, what is our conclusion? What is our conclusion?
That is, in order to identify the outer layer, there is
No, leave alone outlier matter, whatever, madam. Now,
Over, no?
normality matter. See, we said there is a skewness, right? There is a skewness. Yes or no?
Yes, sir.
Hello. We said there is a skewness or not, madam?
Shivakumar, sir.
Yes, sir.
You have forgotten, 0.394 divided by 0.082, which is 4 point something. So, which is greater than 1.96. So, null hypothesis is rejected.
Yes, sir. Yes, sir.
Right. So, which means there is a skewness. When there is a skewness, which means the data is not normal. Yes or no?
Yes, sir.
Don't forget, madam. See,
Okay, sir.
no problem, madam. You tend to forget, no issue.
I'm
Right.
learning.
See here, 0.394 divided by 0.082, which is equal to 4.8, which is greater than 1.96. So, null hypothesis is rejected. Okay, which means there is a skewness. Since this skewness value is positive, which means there is a positive skewness. Right. Now, what is the meaning of positive skewness? How it will appear? How it will appear? Okay, that I am going to show now. Okay, so if people don't understand, leave it. Okay, so if you have understood, I will, okay, no problem, right? Let us not. Histogram, right? Right. Now look at the histogram. How to infer? Looking at the histogram now. Okay, now internet connection is same. Now, okay, so now if you look at the histogram, in the left hand side, there are higher frequencies. There are higher frequencies. Right hand side, there are values. The frequency is less. Frequency is less, but the higher values are there. Some 60 is there, 64 is there. Okay. So this is a positive skewness. Okay. So what is positive skewness is, let me show into this one. Okay. So positive skewness is, this is the, okay. So positive skewness. Okay. So positive skewness. Okay, so positive skewness is the tail. The tail is on the right hand side. Tail is on the right hand side. Tail. The range is on the right hand side. The range, more range on the right hand side. So this is the positive skewness. Why it is called positive is, if you look at the skewness formula, mean minus, this is the formula, right? Mean, let us put minus median, right? For the sake of simplicity. Mean minus median. If it is normally distributed, all is same, which means mean minus median is equal to 0, which means normal, right? Here, mean minus median, so you will get positive value or negative value. Mean minus median, this is a positive skewness. Mean minus median, what value will get? This is the median, this is the mean. Mean minus median, what value will get? You will get a positive value or negative value.
Negative, sir.
Hello?
Negative, sir.
Positive, sir. Sir, look at the x-axis, sir. Sir, look at the x-axis. So mean value is this value, sir. Hello, sir. Mean
Yes, sir,
value
yes.
is this value. Median value is this value, right? Hello, this will be, for example, if it is 12, this will be 14. Yes or no?
Okay.
14 minus 12,
2.
2, positive.
Okay.
Yes or no? That is why it is called positive skewness. Right? The skewness is mean minus, see, I'm not giving the entire formula. Okay, for the simple understanding, mean minus median. Right? If that value is positive, that is a positive skewness. So in the positive skewness, mean side will be above median. Right? Am I right? Yes or no, sir?
Yes, sir.
Hello?
Yes,
See,
sir. Yes, sir.
look at the x values, right? So this is the median value, this is the mean value, right? Mean minus median, right? So it will be positive, which means mean will be more than the median. Okay, so now, 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 madam should tell me
Yes, sir.
how many people will be less than mean. How much percentage of people will be less than mean value? Now we will have some mean value, right? The age, right? Mean age. How many people will be having in a positive skewness? In a positive skewness, how many people will be less than the mean value? You cannot tell that?
No, sir.
Oh, madam, very easy, madam. See, what is median, madam?
Median is 50%.
50%, right? Right?
Huh,
Yes
sir.
or no, madam?
Less
Let
than
us-
50%.
Right. See, not less than 20%. See,
Okay.
mean is 50% of the people are less than the median, right, or madam?
Yes, sir. Yes, sir.
Yes, right. So now that itself 50%. The median
Okay.
itself 50%, right?
Yes, sir. Yes, sir.
Median itself 50%, right?
Yes, sir.
So now the mean is more. For example, here, let us example, right? Mean age is, let us assume that mean age is 34. Median age is 32. That is why positive, right? Now 50% of the people, okay, less than 32. Now how many people will be less than 34? Definitely more than 50% of the people are not.
60.
No, don't give the percentage. Definitely more than 50% of the people.
More than 50. Yes, sir.
Yes, sir.
That is what I want to tell. In a positive skewness, more than 50% of the people will be less than the mean, less than the average value. less than the average score, less than the average income. So when you take income as a variable, more number of people, they have income less than the average income. More number of people, higher frequency of people. Understood, madam? Hello, madam.
Sir,
Understood, madam?
yes, sir.
Tell again, madam. The positive skewness.
Positive skewness, that is whatever the median value is there.
No, madam. You see, more number of people,
Huh.
more number of people are less than the mean income or mean age.
Sir, if you take an income group as a variable,
Income group, income, not group, sir.
Income.
Income.
the income that less than the mean, more than 50%.
Yes,
Is
more
there.
number of people, sir. More number of people are.
That is the conclusion for the
Yes,
positive.
yes, sir. Yes, sir. Yes,
This
sir.
is
Yes,
vice versa for negative.
yes, sir. Now, okay. Now, see, one more thing you have to tell. One more. That is one point. Frequency. That is why. See, that is why you can see our here. See, this is a positive skewness. See here, more number of people are less than the mean, right? If the mean is 32, more number of, this is a frequency. The length of the bar is the frequency. Yes or no?
Yes, sir.
Length of the bar, more number of people are less than the mean. Okay. Now one more very interesting finding is, see, we say, look at the positive skewness. We say the tail on the right hand side. Tail means here also some income people are there. Here also some people income. See, some people are getting this income also. Yes or no? Some people are having, see, these are all some income, this many people, okay, this income. There are people having this income also. Okay, so otherwise, I will explain. See, for example, right? For example, here let us assume that. So 32 is the median, right? That also actual value I will find out. Now the minimum age is 18. Mean age is 32. But the higher age is 64. In our case, right? Maximum age is 64, madam. Hello, madam.
Sir?
What is the maximum age in our example?
Mm,
64.
yes, sir, 64.
Yeah. What is the mean, madam? 31, 32 something, right? Hello? You have forgotten, now? Very good. So now see, the minimum age is 18. Minimum age is 18. Right? Hello?
Yes, sir, minimum is 18.
Minimum is 18, right? Mean age is, let us assume that 33 or 32, right? So now less than 32, right? Up to 18. So some people are 31, some people are 30, some people are 29, some people are 28, like that. So there are 40, the range, right? In the lower side, the range is 14. Yes or no? 32 minus 18. Hello?
Yes, sir.
In the upper side, our maximum age is 64. Our mean is, let us assume, 32. So above mean, what is the range? 64 minus 32. 32 age category are there, which means some people are 33, some people are 34, some people are 35. So the range is more on the right hand side. More number of people on the left hand side, but range is more on the right hand side. Now how? Let me tell. Let us take Uttar Pradesh. Right? Uttar Pradesh. Right. what happening? There is an average income of the people. More number of people are okay less than the average income. Positive skewness. More number of people, frequency. Right. So many people are below poverty line. Right. So more number of people on the left hand side, that is income less than the average income. The tail is more on the right hand side, which means, right, some people they are having higher income, some people higher income people are there. So now if we assume that 35,000 is the average income, some people are getting 36,000, 40,000, 50,000, 58,000, 1 lakh, 1 lakh, 2 lakh, 5 lakh. So that's the range. The range is more on the right hand side. So that is the typical example of Uttar Pradesh. More number of people on the poverty less than this one, but there are people getting higher income. That is why the average is tilted away that side. Understood, madam? Not understood, madam?
Understood, sir.
Now, okay, you have to take example, madam, then we will understand. Now, let us take this example, right? Example is there. Now, right, what is the mean age that we will write it down? Okay, so now, okay, so now look at the mean. Okay, look at the minimum age. What is the minimum age? 18.
18.
What is the maximum age? 64. Right, madam?
Yes, sir.
Median is 31. Right?
Okay. Mm.
So mean is 32. 31.64. Let us assume that 32. Yes or no, madam?
Yes, sir.
Okay. Now the first point. So 31 people who are having 31 and less, 50% of the people. Then if it is 32, definitely more than 50%. Yes or no, madam? Okay. So now we will look at how many. We will look at how many, then we will look at the data also, right? We will look at the frequency also. Now here, okay, let us assume that frequency. Let us assume that mean is 32. Now, how many people are less than 32, madam? 55% of the people?
Less.
Yes or no?
Yes, sir.
Cumulative is 55, which means till 32, 55% of the people. So more number of people less than me. First point is over.
Yes, sir.
Okay, first point is over. Now the second point. See, 32 is the average. 32 is the average, right? So some people are 31, some people are 30, some people are 29. All right. Till what age people are having? 18. Yes or no? Minimum age is 18. Am I right?
Yes, sir.
So there are some people at 32, there are some people at 18, 19, like that, right? So how many range? What is the range? Less than mean. 32 minus 18, right? Yes or no?
Yes, sir.
So how many people are there? 14, right? 32 minus 18, 14, which means some people are at 31, 30, like that. 14 age category people are there. Yes or no, madam?
Yes, sir.
Understand or not, madam? 32 minus 18, madam. Hello?
14.
14, right? What do you mean by 14? Some people are, see, 31, 1, 32, 32, 29, some people, 28, some people, like that. 14 age category people are there. Am I right?
Yes, sir.
Now above category, there are some people at 64. There are some people at 63, 62, 61, 60, 59, 58, 54, like that. The mean is 32, right? 64 minus 32, how many? 32?
So
Yes or no? 64 minus 32,
32.
32. So which means 32 age category people are there above mean. So the range is more on the positive side, above mean. Clear
Yes,
or
sir.
not clear, madam?
Clear, sir.
No, madam, not clear for you. Very simple, right? Okay, but very simple, madam. More number of people are less than mean, right? But higher, okay, there are people, the range is more on the range of the income. Okay, some people, okay, if the, let us assume that income 32,000, some people are 33,000, 34,000, 35,000. Some people are at 64,000 also. So the range above mean 32,000 category people are there. Okay, but below mean, okay, if you say mean income is 18, only 14 category people are there, so the range is less. Okay, so this is about the positive skewness and negative skewness, right? Okay, so now very simple, but you have to see, you need to visualize the data, very simple. But okay, so one statistics professor, he has asked me, okay, we were discussing about the positive skewness. When I said this income with example, he was telling, oh, sir, what is this, sir? So this, I've never seen a person giving this kind of interpretation to positive skewness, sir. So he was telling, right, very good. So now this is about the positive skewness. Now we have all the data. See, for example, okay. So now I will age of the investor. So we have seen positive skewness. Now I am going to show one data. Now let us see how madam is giving by looking at the graph.
Oh my God.
So it is also age, but it is not the age of migrant laborers, age of investors. Yes, some people are in the queue, some people are waiting room. Till 8 o'clock, some people are in the waiting room.
However, sir, actually 1,400 registered, sir.
Okay,
But
okay,
yesterday
sir.
500.
Okay, sir. Okay, sir. Now, no time, sir. Okay. Okay, madam. This
Yes,
is
sir.
skewness, madam. Well, look at the graph and look at the diagram. You tell me, madam.
Yes, sir. By looking into the left hand side, we can see the negative skewness that is pale in the beginning itself. Mhm.
Mudiyalaya, madam.
Sir, this is negative skewness.
This is negative skewness. This is negative skewness, right? So this is the typical example for negative skewness, right? So negative skewness will be, so the mean will be here, mean will be here, median will be here, right? Mean minus median minus value will come, right? So now look at the graph, look at our this one. So okay, look at this one. So this is the negative skewness.
Yes, sir.
So tail will be on the left hand side. Tail
Hmm.
will be on the left hand side, right? So this will be on the, this is the most wonderful example for the negative skewness, right? So now, so here also you can see, okay, so Stem and lymph
Hence,
nodes
only
also. Okay. Okay. Here, see. Here, this side. So negatively skewed. So here also it is deviating. So negatively skewed. Okay. So look at this one. Skewed. Madam, can
sir.
you see? Can you see
Yes, sir.
where outliers are there?
It is. It's showing below.
At the bottom, madam.
Yes, sir. In the bottom, outlier in the bottom.
That is, which means the range is more on the left hand side, bottom side.
Okay.
So this is the negatively skewed,
Okay.
right? So now how it is calculated, all these things you know, right? Very
Yes,
good.
yes, sir. Sir, if it is top, that will be the positive. If it is
Madam?
mm,
Some values are here, outliers
okay.
on the top, so which means there's a possibility of positive skewness.
Yes, sir. Yes, sir. If
Okay,
it is
so
in the bottom,
yes, madam. Outliers are in the bottom, which means that more ranges are there in the bottom. That is the meaning. Okay, so now, I have to tell courtesies and okay. So now, our Tamil Nadu is the best example for the for courtesies. So which means more number of middle income people will be there. So there will be okay. So there will be a courtesies, but okay, leave it. Okay, so. Uh, so you require okay. So this is the normal curve. If this one leptokurtic is right. We will take one example for leptokurtic or some kurtic. Age of the migrant outlier removed. Okay. Skewed. Years of migrated life. Leptokurtic. Okay, very good. Years of the migrated life. Everything is there in the PPT. Which example I should take?
mm,
Years of the migrated life. Years of the migrated life. So the example for leptokurtic. Okay, so years of the migrated life, right? Which means the migrant laborers, how many years they are living in the migrated place.
screen is not visible, sir.
Screen is not visible.
Mhm.
மேடம் இந்த நேரமும் நம்ம கூட இருக்கும் migrant age. So now can you see the experience,
Yes,
madam?
sir.
Yeah.
Yes, sir. Yes, sir.
Now, right, madam? Now, okay. So analyze,
Okay.
right, to start descriptive statistics, explore, right, experience. Okay, so the plots. So normality plots. So now continue. Okay. Okay, sir. Okay. So now இதை பார்த்தாலே படார்னு மேடம் சொல்லிடுவாங்க.
Positive.
Okay, very good. Okay, so இதை பார்த்தாலே ஏதோ சொல்லிடுவீங்களா மேடம்? Okay, very good, madam. We will calculate. We will calculate one by one. Right, very good. So now, right, what is the skewness value, madam? 1.90.
1.90.
Okay, so 1.90 divided by 0.08.
0.082.
What is the value, madam?
Okay, no, sir.
You do not have a.
Mhm.
So now I have 1.90 divided by 0.082. Yes or no, madam?
Yes, sir.
It is equal to 23.17. 23.17. What is the meaning, madam?
It is more than 1.96. And it is more than 1.96. That is, we need to reject the null hypothesis. Accept the alternative one. When it is null hypothesis, there is no skewness.
புரியல மேடம், என்ன சொல்றீங்க? What is null hypothesis, madam? What is null hypothesis? இதுல என்ன குழப்பமா போச்சுடா? What is null hypothesis, madam? யாராவது சொல்லுங்களே, நிறைய மேடம் இருக்காங்களே. Somebody, why don't you tell? We have to trouble only this madam.
The skewness.
1 minute.
Madam, நீங்க ஏதோ மானசா மேடம், நீங்க அக்ஷதா மேடம், you said they are all not responding, madam.
I don't know, sir, why they are not responding.
Any
Sir, I am
participant can-
responsible for maintaining technical sessions, sir. I am admitting the participants, so I am not able to see this
Don't
screen.
admit, madam. After some time, you are admitting, madam, unnecessarily.
Yeah, okay, sir.
Sir, there was positive skewness, sir.
Now, what is null hypothesis, madam?
No skewness.
Madam, சொல்லுங்க.
No skewness, sir.
சொல்லுங்க, சும்மா சொல்லுங்க. நான் திரும்ப சொல்லுவேன். நான் என்ன உங்களை திட்டவா போறேன்?
There is no skewness, sir.
There is no skewness. ஏன் இவ்வளவு குழப்பம்? ரொம்ப
Sir,
ரொம்ப 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 very very easy, madam.
Sir, two possibilities are the same. We can say
No,
that-
madam. Very very easy, madam.
Oh.
When we want to find out skewness, null hypothesis is there is no skewness. முடிஞ்சு போச்சு. No, அவ்வளவுதான். No, madam. Hello?
Yes, sir.
No, that's all.
Okay, sir.
Yes or no, madam?
Yes, sir.
Okay, no skewness, right? Now, what is the rule? Okay, when based on Z value, right? I'm telling again and again, based on Z value, I'm telling. When the Z value is less than, okay, greater than 1.96, we should reject the null hypothesis. எழுதி வச்சிருக்கீங்களா இல்லையா?
Yes, sir.
Yes or no?
Yes, sir.
Right. So now no skewness is rejected. Yes or no? Yes or no?
Yes, sir.
Okay. இப்போ மேடம், see for example, okay, உங்களுக்கு கல்யாணம் ஆயிடுச்சா என்னன்னு எனக்கு தெரியல. Some person, okay, he is going for seeing a girl, alliance. ஒரு பொண்ணு, he is going there to see alliance. Right? Right. When there, அந்த பொண்ணு பிடிக்கல, rejected. அப்ப என்ன பண்ணுவேன்? What he will be doing? He will be looking for another girl. Yes or no?
Alternative girl.
Alternative girl. Yes or no, madam? Hello?
Yes, sir. Yes, sir.
So when no is rejected, then alternative is yes. We have. Okay. So which means no skewness is rejected, which means there is a skewness. Yes or no?
Yes, sir.
Yeah. Now, okay. Now we need to see whether it is positive or negative. Our skewness value is 1.9. Yes or no?
Yes, sir.
So is it a positive? 1.9 is a positive or negative?
Positive.
Positive, which means positive skewness.
Okay.
Correct?
Yes.
Okay. If let me show the diagram, right? Let me show the figure, right? இப்பதான் நான் உங்ககிட்ட சொன்னேன் நீங்க when you see the diagram itself you will tell box plot பாருங்க எங்கிட்ட இருக்கு மேல இருக்கா இல்லையா
மேல sir, top.
பாசிட்டிவ் னு சொன்னமா இல்லையா
Positive only, sir.
that's all. இங்க எவ்வளவு இருக்கு பாருங்க அதனால தான் 29 it is coming, right?
Yes, sir.
Okay, see the value even if it is more than 1.9 it is okay. 29 too much. Okay,
Yes, sir.
very good. Okay, 1 point is over. Now let us look at this one. See here, right? More frequency, more number of people on the left hand side, but the tail on the right
Tail on
hand
the right hand side. When tail is the right hand side, that
Positive
is the positive
skewness.
skewness.
Very good. Second point is over, right?
sir.
So now the skewness point is over. Now let me go for a kurtosis point, right? So now kurtosis point is, right? What is the kurtosis value? 5.138.
5.138.
Standard error is
0.163.
Now let me go there. Okay, so now kurtosis value is 5.138. Standard error is 0.163, which is equal to 31.
That is also more than
1.96. So the null hypothesis, no skewness is rejected. Right? Null hypothesis is rejected.
Rejected.
No skewness is rejected. No kurtosis is rejected. Which means there is a kurtosis. Yes or no?
Yes, sir.
Now, how to find out whether it is a leptokurtic or platykurtic?
Oh.
Now, right? Okay. It is not plus or minus. Here, when the kurtosis value is more than 3.
Okay.
When the kurtosis value is more than 3, then leptokurtic, leap higher. When the kurtosis value is less than 3, it is flat. All right. Here, what is the kurtosis value? 5.138.
Yes, sir.
Is it more than 3 or less than 3?
More than 3.
Okay, which means leptokurtic. Leptokurtic, right? So here also I have written the mean age is 4.26. Okay, so the maximum mean is, look at the maximum is 25, minimum is this one. That is why the spread after mean the spread is up to 25, 4 but to 25, but the less side 4, 3, 2, 1. That's all. Okay, so more number of people are okay. Then now it is leptokurtic. What is leptokurtic is, let me show. Okay, let me show leptokurtic, right? Let me show the diagram. Okay, what is leptokurtic? I think I have completed. Okay. So here, this is a platykurtic. This is a leptokurtic. Okay, leptokurtic, right? So now here, see here, leptokurtic frequency. This is the bar. The bar is frequency. The bar is frequency. The bar is frequency. Right. So now, see the mean is right. So the mean experience is 4. Where it is right. Mean experience is that is mean years of living is 4.26. See, higher frequency, right? Because it is a leptokurtic. Higher frequency. Okay, higher frequency, leap, right? Higher frequency, that is more number of people. Higher frequency, more number of people are in 4 years, and this side 3 years and 5 years. So which means more number of people are around the mean. That is the mean. Leptokurtic means frequency higher in the mean value. So this is the mean value. This is the mean value. So middle, this is the mean value. The frequency is high. So this is the 4, this is 5, this is 3. So more frequency are in the mean and around mean. Here less frequency. You see here lesser frequency. That is the interpretation for leptokurtic. Okay, so if it is plateaukurtic, right? So the frequency is spread. Frequency is spread. Okay, so no more number of people spread across different levels. There is a spread. Here also same people, here also same people, here also same level of number of people, here also same number of people, here also same number of people. The frequency is spread at different age levels. Clear, madam?
Yes, sir.
Yeah, very good, madam. So how to interpret the kurtosis? How to interpret the, okay, so skewness, right? So now I request everybody to please, all examples are given, go through this PPT. All are calculated, all values are there. Okay, so how, for example, the spread is more number of people are around the mean. It is written, everything. Okay, so you can see how, look at this one, how there is no this one. Okay, one more that I have forgotten. Okay, that I will tell. There is a test, simple way. There is a test, right? There is a test, right? Okay, don't look at the skewness and kurtosis. There is a test. There are 2 tests for normality. One is called here in SPSS. One is called Kolmogorov-Smirnov. Another is called Shapiro-Wilk. All right. Null hypothesis is there is no skewness. There is no skewness. Right. Now I'm going to tell in a different form by looking at the significant value. Now by looking, now I have, now I am using a test. I'm using a test not based on
Drishya too.
right. So now if
Ma.
you, now madam, please write down, madam. Please write down.
1 minute, sir. Some disturbances there. I will mute them. 1 minute. Sir. Somebody is disturbing.
Okay.
Yes, sir. Yes, sir.
Now, all right. See, already we have seen, right? When the t value increases, significant value will come down, right? So now by looking at the significant value, if the significant value is less than 0.05, then we have to reject the null hypothesis. Madam, written, madam?
Yes, sir. If significant value is less than
0.05, then reject the null hypothesis.
yes, sir.
Right? Okay. Now here, okay. So now here, what is the significant value?
Here
0.00,
0.00
which is
less than 0.05.
so which means we have to reject the null hypothesis.
Yes, sir.
What is null hypothesis? There is no skewness,
No skew.
which is rejected,
Yes, sir.
which means there is a skewness.
Yes, sir.
Yes, sir.
Yes, sir.
என்ன மேடம் வார்த்தை வர மாட்டேங்குது, என்ன இதுலயே குழப்புறாங்களே மேடம். See, when no is rejected, which means there is a madam.
Yes, sir.
Madam, இதுல அப்போ உள்ளது you are getting confused. So no is rejected means there is a
Alternative.
there is, when no skewness is rejected, which means there is a skewness.
Okay.
Clear or not clear, madam?
Sir, clear, sir, clear.
So Sapro will also same. So now already we have seen by looking at this skewness, there is a positive skewness, positive and leptokaretic, right? Same result we are getting, right? Here also we are telling there is a skewness, which means data is not normal. When there is a skewness, data is not normal. Clear, madam?
Yes, sir, clear, sir.
Right, madam. Okay, very good. Right. Okay. Very good. Okay. Now, now. Okay, so that is also written here, right? Okay, we are going back to original days, right? Madam, can you see the PPT?
Yes, sir.
Yeah,
Yes.
very good. Now, there are 4 types of data. One is called nominal, another is called ordinal, another is called interval, another is called ratio, right? So, if it is nominal, frequency, when it is ordinal, frequency, when it is interval, mean, when it is ratio, mean. Correct, madam?
Yes, sir, correct, sir.
Correct. Now, this also I have saved. So now I will go to another PPT. That is the data entry. So now we are going for a 2 variables. Okay, 1 variable over, right? For 1 variable, we can use descriptive statistics only. So descriptive statistics may be frequency or mean. Other things leave it. Okay, other things leave it. Okay, descriptive statistics, frequency, mean. Okay, for single variable, we can use only descriptive statistics. Right, madam?
Yes, sir.
Either mean or the frequency. Yes or no, madam? Right.
Yes, sir.
Now, I am going to take bivariate situation. What is bivariate?
More than one variable.
No, what is bivariate? No, more than one.
Oh.
Bivariate means 2, madam, not more than 1. 2.
2.
Bivariate means 2. We are going to take 2 variables.
Okay, sir.
Right. 2 variables means we are going to take 2 columns. We are going to take
2 columns.
2 columns. Why? Because variables are in the columns. Yes or no?
Yes, sir.
Variables are in columns. Column 1, column 2. Okay. Now, okay. Now we are going to take 2 variables, 2 columns, right? When you take 2, first column may be nominal. Yes or no, madam? It may be gender. Yes or no? One variable may be gender.
Yes, sir.
Right. So another variable may be married, right? Or anything, any options are given. So there is a possibility that when you take 2 variables, now we are going for a bivariate. two variables. When you take two variables, one variable may be nominal, another variable also may be nominal. Madam, possibility, yeah? Yes or no?
Yes, sir. Possibilities are there.
Yeah. Now let us take, there is another possibility. What is the possibility? One
Nominal.
variable may be nominal,
Another
another
one may be
variable may be ordinal.
ordinal.
Like that, one variable may be nominal, another variable may be interval. One variable may be nominal, another variable may be
Ratio.
ratio. Right. Then one variable may be ordinal, another variable may be ordinal.
Yes, sir.
Another ordinal, interval. Ordinal, ratio. Interval, interval, ratio.
So whatever.
Like this. When you take two variables, there is a possibility to have 10 different option combination possibility.
Okay.
Okay, pre-law you can occur. That is a possibility. Right. So now 10 different combinations. Right. For each combination, when you use one test, you require 10 tests. Because 10 combination, 4, 7, 9, 10. 10 different tests. Already people are struggling with the statistics. When you have 10, the mind will explode. Okay. Now, I want to reduce these combinations so that number of techniques required may be less. I want to reduce these combinations. Is it possible to reduce the combinations? Where is it possible?
We can reduce.
How?
If you want to reduce.
We don't know, sir.
Don't know, sir. Seriously. Don't know.
Madam, simple, madam. Very, very simple. Okay, so don't, just think it, madam. It will come. Okay.
We can group, yes, sir. We can group it, sir. Ordinal, nominal, like that. Or unwanted data we can delete.
Now, what is analysis? Analysis is how we are treating that variable, analyzing that variable, right? How we are analyzing that variable. Yes or no, madam?
Yes, sir.
Yeah. How we are analyzing, thinking, or treating. Now, look at the nominal. For nominal variable, what analysis we are doing?
For nominal frequencies, sir.
Okay, what do you mean by frequency? Counting each, how many ones are there, how many twos are there? Yes or no?
Yes, sir. Yes, sir.
Yeah. For ordinal variable, what analysis we are
That
doing?
is also frequency, sir.
What do you mean by that? We are counting. Yes or
Yes.
no?
Yes, sir.
So,
Yes,
which
sir.
means the treatment given to nominal and the treatment given to ordinal is same.
Yes, sir.
Then why you need to have two?
Hmm.
We are treating the same way, both nominal and ordinal.
Yes, sir.
Then why we should have two?
You can make it one, sir.
We can make it one.
Yes, sir.
Okay, because we are analyzing,
Yes,
treatment, treating. We are giving the same treatment. So then why we have to study separately? Not necessary. Okay. So we can combine this. Like the same for interval and ratio, we are taking average, adding and dividing by numbers. So the treatment given to interval and ratio is same. Okay. So now you need to, the one thing you should not forget, I will test the madam tomorrow.
Okay.
How to identify nominal, ordinal, that is very, very important. Without that, we cannot do anything. Right, very good. Now, the treatment given to nominal, ordinal same. Let us not have two, let us make it as one.
Okay.
Treatment given to interval ratio is
And ratio.
same. We will have it as one. So we can have 2, right? Not 4, right? Yes or no, madam?
Yes,
Right.
sir.
So now nominal ordinal frequency, interval this one. So for nominal ordinal, okay, so we can combine and we can call it as 1. Now, okay, so now we need to give what is one name. We need to give one name for it. We are going to combine it. We are going to combine and we are going to call with one name. What name we can give? I can tell frequency based variable. Yes or no?
Yes, sir.
Yeah. But what is this frequency based, sir? Not good, sir. Sir, you give some name, attractive name, sir. Okay. What name we can give? For a nominal data, what is the example, madam?
That is
Male and female.
Gender, right? Gender.
gender.
Nominal variable gender. Yes
Yes,
or
sir.
no, madam?
Yes, sir. Yes, sir.
Okay. So that you should not forget, madam. See,
Yes, sir.
nominal variable means that is the world example. If you take any book, they will take that example, right? So now in a gender we have in our example we got
Male and female.
Male and
two.
female
We got two.
variable.
We have two.
Variable.
Madam, we have two
Categories, sir.
categories.
2 categories. Male and female.
Male and female. Yes or no? Don't say two variable, madam. Variable is
2
gender. only.
category.
Okay,
Two
sir. Okay.
category.
Okay, sir. Okay.
Variable means gender is the variable, madam.
Okay, sir. Okay.
Okay. Two
Ah.
category, two options.
Sir.
Okay. Now, what is the example for ordinal? What we have taken? Education. Yes or no, madam?
Yes, sir. Education.
In
Education.
education, we had
Order.
Order school.
in our
Order.
in
4
our example,
category.
we had
Four
4
categories.
category.
four
categories.
categories. Yes or no, madam? Four
Yes,
options.
Yes, sir. Yes,
Yes
sir.
or no, madam?
Yes,
So
sir.
in nominal also we are having category. In ordinal also we are having category.
Mm.
So we can call these two as a category variable.
Okay.
What variable?
Category variable.
Category variable. Category variable means nominal, ordinal put together. We can call it as category variable.
Okay.
Very good. So next, interval and ratio,
Non-categorical variable.
scale, right? Scale, right? Scale.
Yes, sir.
We are measuring. We are using scale, right? See,
Yes, sir.
in that measure, we have put it as scale, right? Nominal, ordinal, and both we will put it as one scale.
Mm.
Scale, measure, metrics. So metrics are measured with scale. Metrics are measured with scale. Any metrics can be measured with the scale. Any metric is measured with scale. So interval is a scale variable. Ratio is also scale variable. So metrics are measured with the scale. So we can call interval and ratio as a metric variable. Interval and ratio as a metric variable, right? So now Sivakumar sir is telling. So that is a category variable. This is a non-category variable. Is it right or wrong? Is it right or wrong, madam? It is right, madam.
Right,
It's
right.
Because we have two, no, madam. See, for example, right? See, madam, right? Madam, I can say female. Otherwise, what I can say? He is not male. She is not male. Can I tell like that?
Yes, sir.
But is it good?
No.
No.
You have to tell I am a female, yes or no?
Yes, sir.
But it is not wrong if we tell I am not male.
Huh.
But it is better to say female. Yes or no, madam?
Yes, sir.
Very good. So first is category variable, another is metric variable.
Metric variable.
But people used to say that is a category variable, this is a non-category variable. Otherwise, they will say this is a metric variable, that is a non-metric variable, they will say. All are right. Okay. Some people they say that is a category variable, this is a continuous variable, they will say. Okay, this is a continuous variable, that is a category variable, discrete variable, they will say, right? All are, but there is a minor difference, but generally we can tell. Generally we can tell. So that is a category variable, is a qualitative data, metric variable is a quantitative data, right? Very good. So now category data options are given. We can find out only for a category variable. What we can find out, madam?
Quantitative data.
No, category variable. What we can find out?
Nominal, ordinal. Sorry.
What we can
Frequency,
find out?
Frequency.
frequency, counting,
Analysis. Yes, sir.
Ah, okay. For metric variable, what we can find out?
mean.
I mean.
Meaningful. Mean is meaningful.
Mhm.
That you should not forget, madam. Right now,
Yes.
madam.
Yes, sir.
Now, okay. We got only two variable, madam. Two types of data, madam.
Yes, sir.
What are the two types of data?
Category.
Category.
Variable.
No, one more. Category data. One more.
Metric.
என்ன மேடம் வரமாட்டேங்குது வார்த்தை மேடம் tell
Sir, the metric, sir.
metric, right? One is category, another is a
One is metric.
metric. Okay, category, frequency, metric, mean. Correct, madam?
Yes, sir.
Only two types of data, madam.
Yes, sir.
Only category and metric. Now, madam should tell me, when I take two variables, what are all the different combination, madam?
2 into 2, 4.
Not combination, madam. How many combination? One by one, you tell, madam. Huh?
Nominal, ordinal.
Nominal la mudinju pochu, madam.
And then
Now
what,
we have
sir?
two. Category
Yes,
and
sir, that
metric.
is category and metric.
Now tell combination. Can you understand what is combination? Now you are taking two variable, madam.
Okay, sir.
The one variable may be
So nominal, another one is
no
interval.
nominal, sir. Nominal over, sir.
Oh.
Forget nominal, ordinal. That is over. Now we have only two, category and metric, sir.
Okay.
Okay.
Alright, nominal, ordinal over. Forget it. Now we have only two, category and metric. Now tell the combination. Variable one may be. Hello, custom apa. Okay, variable
Categorical
one
and
may be.
non-categorical, sir.
One is variable one may be category.
Another may be non-categorical variable.
No, don't say non-categorical, sir.
Metric variable, sir.
Metric
Metric.
variable.
Don't say non-categorical or these things. Okay, now variable one may be category, variable two may be.
Metric variable.
That is one combination. What is the another combination?
Category.
Category.
Metric,
Categoric variable.
Metric.
Metric.
category.
Very good. இதுதான் மேடம் இத சொல்றதுக்கு இவ்வளவா?
Okay.
Okay, so now look at this one, madam. So now variable one may be category, variable two also may two columns. That is why I have shown columns or variables. Variable one may be category data, variable two may be category data.
Yes,
Next,
sir.
that is
Next.
one possibility. What is the
Next.
another possibility?
Metric.
Category,
Variable
metric.
may be category, variable
Metric,
two may be metric. What is the another possibility? Variable one may be metric, variable two may be category. Then variable one may be metric, another may be metric. Hello,
Yeah.
madam.
Yes, sir.
Are you married, madam?
No, sir.
Not married, huh? Okay. So now, okay. So now you are the okay. So now Sivakumar sir, are you married, sir?
Married, sir.
Married. Okay. So now what happens? Now Sivakumar sir and Hello?
Good.
நான் கிளாஸ் எடுத்துக்கிட்டு இருக்கேன் few minutes அப்புறம் 8 o'clock அப்புறம். Okay, bye. So now, see Sivakumar sir and his wife, both people are going to cinema theater. Yes or no? Okay, so they are seeing the multiplex and they are seeing the movie. Right. Now, the okay, so Sivakumar wife, she is sitting in the aisle seat, and Sivakumar sir sitting in the next seat. Okay, both are watching the movie. Sir, are you there, sir?
Yes, sir. Yes, sir.
You are
I was-
watching the movie, right? So now interval has come. Okay, so the Sivakumar sir is simply sitting. Then after 1 or 2 minutes, his wife is beating. Hey, why are you sitting? Simply sitting. Go out and buy something. The wife is beating him. Right. Right. So Sivakumar sir went out. Okay. So he has purchased some popcorn. Since he has went late, so when before he could come, okay, they have switched the light. They have switched off the light. So he is coming in the night without light. So this Sivakumar sir wife, earlier she was sitting in the aisle seat, right? Now what she thinks about this boy, this man will come, he will struggle and he may fall on me. Okay, let me avoid. So she is going to the next seat, the other seat, leaving the aisle seat to sir, right? Sir has come, so there is a seat here. He is sitting here now. Understood?
Yes, sir.
Right. Now, okay. So when there is one joke is going on, but Sivakumar sir simply sitting. Okay, the wife, நல்ல joke போது சிரிக்காம ஒரு குத்து, again some beating. Okay. Now, earlier, the madam is sitting in the aisle seat, Sivakumar sir in this seat. Sivakumar sir, wife. Now what happened? Okay, Sivakumar sir this side, wife is this side. Yes or no? Okay, so whether that lady is same wife or different wife? Hello, sir.
Same, sir.
Same wife, right?
Same,
So
sir.
now whether she is sitting on the left hand side or whether she is sitting on the right hand side, same beating. Earlier also she has beaten, now also she is beating.
Yes, sir.
Yes or no?
Yes.
See now, whether she is sitting on the right hand side, whether she is sitting on the left hand side, she is same wife, giving the same beating. Yes or no, madam? Nandini, madam.
Yes, sir. Yes, sir.
Now, why I am telling this story, madam?
This is the
So
example
two type
for
of data,
categorical
whether
and
it is
metric.
category or metric, wherever it is, same combination. Possibilities are there.
5 minutes I wasted, madam. But you have understood that I am happy, madam. So,
Thank you, sir.
okay, so these two, okay, same thing. Okay, whether it is this side or that side. Okay, so no different. So now we have only 3 options. One is category, metric, metric. Only 3 options.
Okay, sir.
Okay. So now, when you have category, then you have to use chi-square test.
Okay.
So chi-square test, both variables are category. For a category, we can find out frequency. So chi-square test is a dash-based test. Chi-square test is a dash-based test. In a dash, it is a frequency-based test. Can I tell or not, madam?
Yes, sir.
Okay, because we are using both category.
Category.
Category means frequency.
Frequency.
It is a frequency-based test.
Yes,
Now,
sir.
one is category, another is metric.
Okay.
Then you have to use ANOVA. Okay, ANOVA is a big family, independent sample t-test, factorial ANOVA, all ANOVA. Now, when both variables are metric, then we have to use correlation. Hello?
Yes, sir.
So now tell madam, category,
So
category,
category,
test.
chi-square test,
Chi-square
category and metric is ANOVA, metric and metric correlation.
Very good. Right. So now to decide the analysis, you need to decide whether it is a category variable or metric variable. Am I
Okay.
right?
Yes,
Am I
sir.
right, madam?
Yes, sir. Yes, sir.
So otherwise you cannot use wrongly. So that understanding is very much required, right? With this, we will stop today.
Yes, sir.
Right now,
Yes,
if
sir.
we have any questions, we will take up the questions.
Okay, please raise your hand. 3 questions, sir will answer. Please raise your hand. Please raise your hand. If anybody have question. Yes, sir. Varsha.
Varsha Kotwal.
Yes, sir.
Madam. Yes, many people are coming. Yes, Varsha Kotwal, madam. Yes.
Please repeat again this CCMM and CM category metric.
Repeat your question, ma'am, please.
She is asking me to repeat, sir.
Yes, sir.
Category C means category variable, madam. Another C means category variable. So when you take two variables, right? What you mean by variable? Let me show. Right. Let me show some example. Right. Then you will understand. Okay. So for example, right. Okay. Now, for example, let me take one example. So now I have two variable. One column variable 1, variable 2. If variable 1 is category, variable 2 also category, then you have to use chi-square test. Right. Then second one, when the variable 1 is category, variable 2 is metric, then you have to use ANOVA. Right. Then another combination is metric. When both variables are metric, then you have to use correlation. We have only 3 combination possible. Only 3 combination. Because types of data is only 2. So when you have only 2, we have only 3 combination. The fourth combination madam was telling, which is nothing but the repetition of category metric or metric category. So whether this side, that side, it will not make any difference. So this metric category is removed. We have only 3 options. Okay. So 3 option, 3 analysis, right? So the regression and other things we will tell, okay, that is also metric. So that we will tell later. Only 3 different analysis, right? Regression is also based on correlation. So only 3 different analysis are available. Okay. So now I think madam understood, madam Varsha, madam. Whether I answered your question, madam?
Varsha, ma'am.
Varsha, madam?
Okay, sir. No reply, sir. Next, sir.
Bhargati Bushra.
Yes, sir. Bhargati Bushra, please ask your question.
Good evening, sir. I don't have questions, sir. It's very insightful. I wanted to ask Shiva, sir, will we get the access of recordings?
That you put the mail to Sivakumar sir, he will respond.
Shiva, sir, please kindly reply. Will we get the access of recordings? Because it will be very insightful to go back and forth. Sir is really teaching very awesome.
Sir will teach like that only, ma'am. We are missing their offline classes. Actually, we are attending in online a little bit, because if you attend offline, that will be extraordinary. But we are missing that. But we have to follow it. Later we decide, ma'am.
No, we
Okay.
will give recording, sir, for few days. Let them understand, sir. Okay, so
Yes, sir,
we
please
put
share
it
the
in the
recordings.
YouTube for some time, sir. Let
Sir,
them.
that okay, sir. We will try, sir, but not now. Only after 10 days, because we will get a package CD after 10 days only.
Ah,
Because
sure, sir. Sure, sir. We will wait patiently for the recordings after 10
ma'am,
days.
100 promisely we will definitely upload, but not possible now. Only after completion of FDP we will leave with the sir permission. 10 days definitely we upload. Promise.
Sure,
Okay.
sir. Sure, sir. Thank you so much, sir. And
Okay,
sir,
sir.
it's a very heartfelt thank you for the organizers also and to the sir also. He is really teaching very lucidly and very patiently each and every explanation and each and every insight. It's very wonderful to be part of this webinar.
Okay.
Thank you so much, sir.
Thank you, madam. Thank you very much, madam. Thank you.
Okay.
Thank you.
Sir, last question.
Palla Sasigala.
Yes, sir. Last question, sir. Last question. Palla Shashikala. Ma'am? Ma'am? Palla Shashikala, ma'am? No, sir. No response. Okay, sir. We can conclude.
Any more question? We will ask somebody, sir. One more question we will take up.
One more question.
Any more
Okay.
question?
Any more question, candidates?
No questions.
No question. Okay, candidates, there is an important instruction for you. Tomorrow's session will be at 4 o'clock. I will also post in the WhatsApp. Please note it, candidates. Tomorrow's session will start at 4 o'clock, 4 to 6 o'clock. Don't miss, don't wait for 6 o'clock. Okay. This is the gentle reminder. I will also reminder it the WhatsApp in the WhatsApp group. There are 6 group is there. Definitely I will inform. And the feedback form is already I have posted in the chat box also. Please use it and please don't share to every person because we are expecting that active participants should fill the feedback. That is my expectation. Okay. And already I have posted for 3 days feedback and don't again and again chat me and post a message in the WhatsApp to give feedback. Please. Okay. Whenever we want, definitely we collect the feedback. Maybe we next day or fourth day we will collect. Definitely certificate will be issued only on the feedback verification only. Okay. Please attend all the session. Our expectation is to participate. Okay. Please inform to your friends also. This is the information from our organizers. Okay. Thank you. Thank you very much. And please use the feedback. And feedback will be closed after 2 hours. That is the instruction very clear. Okay. Okay, sir. Is it correct now, sir?
Thank you, sir. Thank you, sir. Thank you, sir. Thank
Okay.
you.
Nandini ma'am, what of thanks good to time?
Sir, it is a very informative session. Day 3, we learned about sequences. That is especially the positive positive squeeness and negative squeeness, as well as curtices, especially leptocurtis and the extra things we learned today. With that, variables, especially bivariables, there is combination, that is 2 types of data, that is category metrics. It was well explained, sir. Thank you so much for your patience teaching.
So you have we have identified the outlier also, madam. Outlier.
Outlier.
Okay.
Yes, sir.
So,
Outlier. 2
when
types.
when you have outlier, you have to remove it, madam. You have to remove the data. Then only you have to do analysis, madam. So in the data, you should not have any outlier. If you have any outlier, your mean and other things will get distracted. It will give a different picture, right? Because see, we cannot give conclusion based on exception. They are all exceptionally rich people, exceptionally poor people, right? Or exceptionally getting good marks. If you decide based on the exceptional this one, then your result will be distracted. So we should remove the outlier. How to identify? This is one step. Only 2 things I have given. There are many other ways also. This is based on this descriptive statistics. What can be possible? I have explained. Okay.
Yes.
Thank you, madam. Thank you very much.
Thank you so much, sir. And I also thank our principal, Jairam sir, Seshadripuram Academy of Business Studies. I thank for opportunity, and also I thank our research cell coordinator, Shivkumar sir. And last but not the least, I would like to thank all the delegates from various college participants for joining today's day 3 FDP. And we also look forward your active participation for another 7 days FDP program. Thank you once again.
Madam,
Sir,
Nandini madam, I am very, very thankful. I'm troubling her very much. Okay, even then she is taking everything very sportive manner.
Sir, I am
Actually,
learning-
Nandini madam is the first session and she is at zero, sir. She is every day
sir.
she is improving and learning with SPSS.
Yes,
Actually,
sir.
she
I'm
is
very,
also very
yes, sir.
happy.
I'm learning from zero, sir.
Very good, madam. No worry, madam. No, learn, madam. Write it down, madam.
Yes,
Before
sir.
coming next day, you try to go through, madam. Then only
Yes,
you will remember, madam. Huh?
Yes, sir. Thank
Because
you.
every time when you look at the notebook and tell, then you may not tell the right answer. So it is a homework to go through.
Okay, sir. Okay.
Okay, thank you.
Okay, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you.
So participants, let's we meet tomorrow 4 o'clock. Thank you. Thank you very much.